Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week. And this is going to be an anniversary bonus weather video because 35 years ago today, in the wee hours of the morning, a devastating tornado developed literally right over Umstead Park and traversed parts of Wake County, Franklin County, Nash County, Halifax County, and Northampton County on an 84-mile long path of destruction. We'll talk about some of the weather occurrences and variables that went into that, but I want to start off by sharing with you some personal recollections that I have about that night. Now, it was Thanksgiving weekend, and Sunday was an incredible day. It was November 27th, and temperatures were in the 70s in the Triangle area. People were out in shorts and enjoying themselves, admittedly thinking to themselves, this is a little weird for the end of Thanksgiving weekend, but there were no severe weather outlooks, no watches, no warnings anywhere, not just in North Carolina, but anywhere. And so as a result, we thought a cold front would come through that night rather innocently with a few scattered showers and thunderstorms, and then it would turn colder the next day. Now, I had a friend over that Sunday night, and we were watching the Sunday night NFL football game, and afterwards we were standing outside my condominium at midnight because there was no such thing as a short conversation with this particular friend, and we were commenting on the fact that it's 70 degrees at midnight on November 27th. This is ridiculous, you know. So he went on home, and I crawled into bed, only to be awakened a short time later by a call from the WRAL newsroom, just a little bit after 1 a.m. And they told me there's been a tornado, we need you to come in. Well, in all honesty, periodically we would get calls from viewers that would say, oh, I have a tree down in my yard, I know it was a tornado, and it didn't turn out to be that. So I wanted to make sure this was the real thing before I rushed in. So I called the National Weather Service office in Raleigh, and they said, well, the Kmart on Glenwood Avenue is gone. And obviously at that point, I knew this was the real thing. So I rushed in. Now, a couple of other unfortunate things, which in the end, you know, didn't really have that much of an effect. But the first thing is that at that time, WRAL would routinely take their transmitter down for routine maintenance at 1 a.m. on Sunday night / Monday morning. And so the transmitter was down, and we had no immediate way to get on the air to tell people what was going on. A few minutes later, we did get it back up, but by that time, the tornado had moved over into Franklin and Nash County and was speeding away from us. The other thing is that the tornado developed right over Umstead Park, which is very close to the RDU airport, and so the radar at that time was located at the airport, okay? And so there's a cone of silence with a radar where the beam can only tilt up so much. And so you have this area right over top of the radar that you can't see anything. You can't see what's going on, and you have to rely on surrounding radars to be able to see anything that's over you or over the airport. And so that was an issue. And we didn't have Dopplers back then either. They weren't going to be installed for another several years. And so it was a conventional, what we call a C-band radar that would not have been able to measure velocities even if we didn't have the cone of silence issue. So just a whole bunch of limiting factors going on that particular night. And so the thing that I remember is that, you know, all of a sudden we went from no watch, no warning, no severe weather outlook of any type to, at that time, an F4 tornado. That was on the old Fujita scale. And I don't know if when they went to the enhanced Fujita scale, if they took that back to a strong EF3 or not. Doesn't matter. It was a devastating tornado. There were several tornadoes that night. I think there were 7 of them, but only one was even close, or there was only one that was really significant, and that was the one that affected the Triangle area and moved off toward the east and the northeast. So I want to share with you some data that I was able to go back and collect This took an inordinate amount of time, but I wanted to make sure that I at least got something for you. So let's go on ahead here, and I'm going to put myself down in the corner as I normally do. There we go. And so here is the summary of the path of this tornado. And again, it formed very close to the airport and was labeled as an F4 at that time. And you can see that there were 2 fatalities in Wake County and 2 in Nash County. And it went all the way from Wake County across Franklin, Nash, Halifax, and into Northampton counties. The thing is, when you think about this, obviously 4 fatalities were 4 too many. And I don't mean that to be a cliche. I mean that sincerely. But when you look at the amount of damage that was done by this tornado, and you consider the fact that there was no watch and no warning, and it happened in the middle of the night, it is a true miracle by anybody's definition that we didn't lose more than 4 people. When you looked at the damage afterwards, it was just, you know, if you were here and you saw it, it was remarkable. It really was. I had never seen anything firsthand like that in my life. 4 fatalities. It says on this graphic 157 injuries. The latest report that I could get my hands on said 154. It was a lot. $77 million in damage, and that was in, I guess, 1988 dollars. An 84-mile-long damage path. No watch, no warning, and the radar was out for maintenance. That's another thing I forgot to mention. And the story that I was told, and I believe that I heard this from somebody that worked for the National Weather Service back then, is that a part had been ordered and the wrong part came in, and they didn't get the right part until after all of this was over. But again, it wouldn't have mattered because even if the radar had been up, you have the cone of silence issue, you have the fact that we didn't have any way to measure velocities with radar back at that time. So I really doubt seriously that it would have mattered whatsoever. Okay, so here are the RDU airport observations, a couple of hours either side of when this occurred. And I mean, look at these temperatures. This is late November, 11 p.m. 71, midnight 71, 1 a.m. 71. And notice that the wind went from south-southwest to south-southeast. Now, what this is indicative of is the fact that if the winds start turning like that from a south-southwest direction over to the south-southeast direction, that creates wind shear, directional wind shear at the very least, because the upper level flow was southwest, okay? And so initially, the low-level winds were almost parallel to the upper-level winds. But then, as they became more south-southeast, then you get that veering wind pattern, which is so classic with severe weather. And so that was an indication that something was going on there. And then you notice at 1:04, the gust front with the thunderstorm came through, and the winds gusted to 38 miles per hour at the airport. And then by 2 a.m., temperatures had fallen all the way back to 64, and the winds had lightened up quite a bit, and the thunderstorm was over at that point. And there I'm just highlighting the period of time where the winds turned to the south-southeast, and then the gust front came through with the thunderstorm, and the wind shifted, and the temperature cooled down. Now, this is the radiosonde data from Greensboro at 7 p.m. on November 27th, the night before. And these are the temperatures, wind direction, and wind speeds at all of these different levels that you see there on the left. And there's 2 things that I want to point out here. First of all, in the lowest 5,000 feet of the atmosphere, from 976 millibars up to 850, you saw this veering pattern in the wind. It went from 160 to 174 to 180 to 185 to 198. And look how the speeds increased dramatically. 8 knots, 14 knots, 19, 33, and 47. And so when you have that much speed shear in the atmosphere, what happens is if the winds are light here and they're fast up here, then you start to get a circulation pattern like this. And then when a thunderstorm updraft comes along, it tilts that rotation axis into the vertical, And then you have rotation like this. And so we are always looking for that kind of a wind pattern in the lowest mile of the atmosphere. In fact, sometimes even less than a mile, to give us an indication that this is a favorable setup for the development of tornadoes, or at the very least, rotating updrafts and thunderstorms. And then the other thing is that when you take a look at what was going on up around 35, 40,000 feet, we had a couple of jet streams, but the southern branch of the jet, the subtropical jet, was very, very strong. These are sustained wind speeds, southwest at 113 knots at 250 millibars and 126 knots at 200 millibars. So again, when we see that much vertical wind shear in the upper levels of the atmosphere, that is also a favorable scenario for severe weather to occur. And there was actually an interaction going on between two jet streams that night, the polar jet and the subtropical jet, and they were configured in such a way that it contributed to a large-scale upward motion field. But large-scale stuff does not create tornadoes, okay? It can create a favorable overall large-scale environment, but you need something that's much, much smaller scale to be able to get this thing going. And there was an extensive amount of research done after this storm, and a lot of the research indicated that a gravity wave, which instead of being a horizontal wave, like when you look down on a weather map and you see, the flow curving, a gravity wave is a vertical wave where the air is going up and down like this. And it has to be stable, the air has to be stable, or like having an inversion right above it, and it creates a ducting environment where it allows this gravity wave to keep moving along without weakening. And they were actually able to find a gravity wave near the Gulf Coast, I believe down around Louisiana, that propagated toward the north and east. And then when it got to North Carolina, it intersected with a boundary between the warm air that was over us and some rain-cooled air that was just to our west. And the theory is that that was the mechanism that actually set off the thunderstorm that then produced the strong tornado. So, and the only way you can see these gravity waves is by taking a look at pressure changes by the minute, okay, or at least every 5 minutes. If you take a look at pressure changes over an hour's period, you'll never see these things. They're that small scale. But when you actually take a look at the 5-minute ASOS data from all the different observing stations, then you can make out these little patterns where the pressure will fall here and rise here, and you can follow this little couplet right along. And from all indications, that played a major role in what happened that particular night. All right, I know that was long-winded, but this is an important event in North Carolina weather history. And obviously the people that suffered the loss of life and their family will obviously never forget this. And it was quite a traumatic experience for an awful lot of people. So 35 years ago today, it's just hard to imagine that that many years have passed since that night. All right, folks, that is bonus weather video number 1 for this week. The next bonus weather video will be coming up on Wednesday, and the next daily weather update will be coming up later today. So you all take care, and we'll talk to you then. See you later.